Okay, in this video, I'm going to review basically just how to find a domain of a function. And if you remember domains, right, recall domain is the set of all input values. Okay, input, what's input? Just think of x values for which a function is defined. Okay, so basically just think of what is allowed into a function and what's not allowed. Okay, so let's start. I'm going to go over many different types of functions you've studied. Okay, so let's start with a linear function. Now, in a linear function, right, you essentially just have a line, and we'll just call it, f of x is equal to mx plus b. Okay, so we'll call this equation f of x is equal to mx plus b. Of course, you can use point slope. I'm just going to use slope intercept. If I ask you to find the domain, right, if I say, hey, what is the domain of this function? You look at your line right here, right, this particular line. You ask yourself, is there anything that x cannot take on a particular value, right? Is 0 allowed? Clearly 0 is allowed, right? Is 1, is your negative numbers allowed or your positive numbers allowed? If they're all allowed, right, the domain is strictly all real, okay? And we're going to use interval notation now, since we learned it or reviewed it, minus infinity to infinity. Okay, so all linear functions, in general, the domain is all real, okay? Or minus infinity to infinity. There are exceptions to the rule if there's holes in your graph, and that's applicable to any graph. But we'll talk about holes when we cover rational functions, okay? So just think of linear functions. In general, the domain is always all real. The next type of function that you study is a polynomial function, right? And polynomial functions include a wealth of functions, more than just one. What do I mean by a wealth? Well, you clearly studied, f of x is equal to x squared, right? They include quadratic functions. And so if I give you a quadratic, right, of course there's variations to this, right? You can shift it up and down, left and right, et cetera, et cetera. And if I ask you what's the domain, is there anything not allowed into this function, this equation? You think, are positive numbers allowed? Yes. 0 allowed? Yes. Negative numbers are also allowed, right? And you can look at the graph, right? It's going to go on forever to the right, forever to the left. This one's also all real. Okay, and also minus infinity to infinity. Polynomials, that doesn't have to be quadratic. It could be a cubic function, right? If I give you f of x is equal to x cubed, and roughly you should know how to sketch that based on your knowledge of leading coefficients and whatnot. If you don't remember, we will review that. The domain is also going to be all real. Okay, so in general, polynomial functions, the domain is always going to be all real. All right, moving on. Odd root functions. Odd root. Well, what's an odd root? If I give you a function that looks like this, f of x is equal to the cube root of x, right? It's kind of like an S-shaped graph. F of x is equal to the cube root of x. Okay, so again, if this is 3, 5, 7, 9, right? It's applicable to all odd root functions. If I ask you, what's the domain? You can plug in positive numbers. You can also plug in negative numbers, right? Because the cube root of negative 8 is just negative 2. You can plug in 0. The cube root is 0, 0. So you can plug in any number into this equation. And you look at the graph, right? Anything can be inputted into this function. So we say it's all real. Okay, domain's all real. Do I have to write both? No, I'm just, reviewing both inequality and interval notation with you. All right. Now, actually, I'm going to skip to absolute value, and then I'll go over the last two, which are the ones you actually have to do a little bit of work. Okay, so if I ask you, hey, graph an absolute value function for me, you're like, okay, well, absolute value function is just a V-shaped graph, right? the origin should be at 0, 0. So never mind my poor handwriting there. Okay, so you have a V-shaped graph, vertex at 0, 0. If I ask you what's allowed into this function, and you think about it, anything's allowed, right? This one's also going to be all real. Or minus infinity to infinity. Okay, at this point, you're like, what's the point of this exercise? Everything's going to be all real, right? We got odd root, we got absolute value, we've got linear functions, we got polynomials, right? Those ones are nice because you don't have to worry about restricting the domain or finding something that's not allowed. Now, the last two are the only ones that you're going to have to do a little bit of work, okay? And I saved those last two for the end. Suppose I give you an even root function. An even root. Okay, well, what's an even root function? What if I give you f of x is equal to the square root of x? Okay, so I mean this is 0, 0. And this is my function. F of x is equal to the square root of x. How would you find a domain? Well, if you just look at the graph, right? The graph tells us that x never goes past 0. In fact, it equals 0, right? So I'm going to say x is equal, it's not equal, x is greater than or equal to 0. For interval notation, you would write, now you know, right? You would write 0 inclusive all the way to infinity, right? That would be the domain of an even root function. Now I'm just going to pause briefly here before I move on. That's if you just look at the graph, right? But how would you solve for the domain if you just look at this equation over here? Whatever's inside of this equation is actually called whatever's inside the square root is called the argument. Okay, so a little bit of vocabulary here. The way you solve it algebraically, okay, solve domain algebraically. Step number 1 for even root functions, set argument greater than or equal to 0, and then you solve for x. Okay, just those two steps. That's how you solve the domain algebraically. So if I go back and do this problem, right, all I do is just set the argument, right, greater than or equal to 0, and I solve for x. And that's it. There's not much I can do, right? X is already by itself. Okay. So you'll see in the examples, how do I find a domain without looking at the graph? Okay, so even root functions. Now this example I gave you was square root, right? It applies to 4th root, 6th root, 8th root. So it's applicable to all even roots, okay? All right, so that's one function where you actually have to do work. The very last one is called a rational function, right? This is the topic that I said is very important in Math 3 and also here in Math Analysis. And let me give you a simple rational function. Okay, what if I give you, f of x is equal to 1 over x? Okay, if I ask you to sketch that for me, roughly you should tell me this is what it looks like. Okay, so that's what a rational function looks like. And if I ask you, hey, what's the domain? Just looking at the graph, you would say, well, it looks like the x value can be negative, right? It could also be positive, but it can't be 0. So you would say all x cannot equal to 0. And the way you write interval notation, right, is minus infinity to 0, union mark 0 to infinity. Okay, so that was the last example I did in the domain, in the interval notation video, the very last example. So take a look at that if you're not quite sure how I got this. Okay. All right. Now, how do I do this algebraically for a rational function? It's fairly straightforward, right? You set your denominator equal to 0. Solve for x. And then exclude those values, okay? So this one has 3 steps. So if I go back to my function, right, let's say I give you something simple like this, 1 over x plus 1, okay? So if I were to solve for the domain algebraically, I'm going to set my denominator equal to 0 solve for x, right? And then the last step would be x cannot equal to -1. So I would say all x cannot equal to -1. That would be the domain of this particular function. Okay, so that is a quick review of all the major functions that you're going to be studying in this course, or at least reviewing, because you've seen it before in Math 3 or Algebra 2. And the only two type of functions that you have to do some work in are even root functions and rational functions. And I showed you how to solve it algebraically. Okay.